Okay, so continuing our previous class, we were discussing about its properties. We were done discussing about these properties from 1 to 7. Now let's discuss about 8th, 9th, and 10th property. These are all based on inequality. And it's dependent on somewhat the relation of its base and the x here and also the result. So for that, I will like you to remind the graph logarithm. Yeah, here it is. So when we see the graph logarithm for the base, when the base is lying between 0 and 1, the graph is decreasing. Okay. Whenever the value of x is increasing, the value of x is increasing. And if a is lying between 0 and 1, so the y will decrease. So whenever there is a logarithm, like an inequality, let us say logarithm ax, it is giving us p. Okay. Okay. And if there is an inequality, instead of uh, equality, so what will happen? What will happen if this is the inequality? So basically, in this condition, we will simply do one thing. Whenever there is an equality, simple follow this procedure. That remain, let the x remain here and the base go to the other side of the equality. Now let us decide whether this given inequality sign will change or not. So it will change in the case of when the base is lying between 0 and 1. When the base is lying between 0 and 1. So the inequality sign will change. Why? Because y and x are having a negative correlation here. Means like when when x is increasing, y is decreasing. That's why the inequality sign will change. For this is the case of this condition. For this condition, whenever there is a scenario like this, so let us say logarithm of x to the base a is less than p. So we'll do the same procedure. First of all, we'll write x here and we'll bring the base to the other side of the inequality. Now we'll decide on the basis of a's value whether the inequality sign will remain the same or not, or it's going to change. So here a is, if a is more than 1, then the inequality sign will remain the same. So that is the concept. That is the concept basically. And we also think in mind that a and x must be positive. That's one thing. Understood about this, how we have solved the inequality when it is related to logarithm?
Yes, sir.
Yeah. So same logic is followed here in the given properties also. First, let us understand this. We have discussed about it earlier also, just now. When a is more than 1, when a is more than 1, then the logarithm, then the x will remain on the same side and a will go on to the other side of the equality. Okay. And the sign of inequality is also not changing. Great. What if the given inequality condition is like this? So in this particular condition, we'll send the base to the other sides of the inequality. We have successfully done so. A raised to power p, a raised to power p, a raised to power 0, which becomes 1. Okay, understood till now. Understood? Is that clear till now?
Yes, sir.
Yeah, and here a is also more than 1. So the inequality sign is not changing. Clear?
Yes, sir.
When the base is lying between 0 and 1, so this inequality will be solved in this similar manner that we are going to send, let me write here, that we are going to send, it is given like this, that in this condition, same, whenever there is an inequality, we are going to send the base to the other side of inequality. Now we'll decide whether this inequality sign will change or not. As x is less than 1, more than 0 here, so the inequality sign will just reverse. Okay, so this is the solution for this. And that is same which is given. Why it is written that it is greater than 0? Because x is a positive value. That's why this condition is also true. Understood?
Yes, sir.
Yeah. So let's now discuss about this. Oh my. Let's now discuss about this. So the given inequality is like this. So we'll keep the x here and we'll send the base to the other side of inequality. A raised to power p. A raised to power 0 becomes what? A raised to power 0 becomes what?
1.
Yes. And now the a is less than 1 and more than 0, like a is lying between 0 and 1. So the inequality sign will reverse. So this will be our answer solution here. And it is the same which is written over here. Understood?
Yes, sir.
Yeah. So these are basic properties which we can understand by relating with our concept. Going back to these. So it is mentioned that 0 is like y is more than 0 means y is a positive value and x is also greater than y. X is a positive value and x is greater than y. So in the first condition, it is written that when logarithm of x to the base a is greater than logarithm of y to the base a. So here x is greater than, like logarithm of x is greater than if a is greater than 1. So basically, when x was greater, its logarithm value will also be greater. In the case when the exponent, when the base is more than 1. So we also can correlate this logic that the graph of logarithm of the base more than 1, being more than 1, it was an increasing function, y was increasing, x was increasing. So that's why like there's no issue here. But when we discuss about a belonging between 1 and 0, then the case will turn by because the base is less than 1. So the graph was having the negative correlation, means when x was increasing, y was decreasing. So that's why when x is greater, so its logarithm value will be less than the logarithm value of y. That is the logic behind it. Understood?
Yes, sir.
Good. So the graph, we have already discussed about it. Let's now solve the example. Do you have any questions before it?
No, sir.
Okay. So given our A, B, let me read the question first. If A is logarithm of 3 to the base 2, B is logarithm of 5 to the base 2, C is logarithm of 2 to the base 7, where the base is changed. Then the value of logarithm of 63 to the base 140 in terms of A, B, C. So we have to find the value of logarithm of 63 to the base 140. We can write it as log of 63 divided by log of 140. Correct? To the base e, of course. So we are not right. We are going to write e again and again. So now let's take what we are trying to do here, that we will represent 63 in terms of 3, 2, 3, 5, and 2 and 7. Okay. So let's do the prime factorization of 63. 63 is what? 3 into 21, 3 into 6, 7, right? 9 into 7. So 3 raised to power 2 into 7. We can write 63 like this, right?
Yes, sir.
What about for 140? 4 into 5, 20, 20 into 7, 140. Correct?
Yes, sir.
So now we have written the like whatever given expression was, whose value we had to find out. Now we have written in the format of 3, 5, 7, 2. So something it is matching with A, B, and C. Okay. So now let's try doing some things with it. Let's expand. So logarithm of m into n was logarithm of m plus logarithm of n. Understood? How have I written so?
Yes, sir.
A logarithm of 2 plus logarithm of 2, so it is twice. plus logarithm of 5 plus logarithm of 7. Now it is also that we can bring this power to the multiple here and we can vanish the power here. Great. So now we have like everything in terms of logarithm 3, log 7, log 2, log 2, 5, log 7. But the problem here is a is log of 3 to the base 2, and here we are having in our solution logarithm of 3 to the base e. So now let's try converting ABCs into our convenient form so that we can write and use in the answer expression. So if we go on and divide logarithm of 2 in the numerator and as well as denominator, so we will have logarithm of 3 to the base 2, which is the a. So we can do that, right? So dividing logarithm of 2 in numerator and denominator. So 2 logarithm. So what I'm going to do that we are going to divide logarithm of 3 by logarithm of 2. So it can be rewritten as, please speak. Logarithm of a to the base b. So now what will it become?
Log 2 in the base, then 3 upon yes.
Right. So same goes here and same goes for the log 7 also. And log 2 by log 2 will become what?
1.
Yeah, good. So 2 into 1, 2. Logarithm of 5 to the base 2, logarithm of 7 to the base 2. So now we can substitute this. This is what? A. 2a plus this is what? Tell.
Uh,
Please try. Please try. This is what?
log 7.
So this is what?
Is it C, sir? No. 1 by C.
By C, yes.
Ah,
So 2 plus what is this? B plus what is this?
and 1 by C.
1 by C. So now taking C LCM, so 2AC plus 1 divided by C. And here also taking C LCM, 2C plus BC plus 1 divided by C. C will cancel C. What it has become? 2AC plus 1 plus 2C plus CB plus 1. Yeah, so the option number A is answer, like matching with the answer. Is this question clear to you? We have played with log.
Yes, sir.
Yeah. Example number 2. So now we have given with the equation. Now we have to find out the value of x. So there is only one variable in the equation, so it will be an easy task, right?
Yes.
So 3, let's bring this 3 to the power 2. Let's simplify and remove the log. And logarithm of 10. 1 minus x square. Now, this 2 will be an obstacle for us because I will go on to write this logarithm base 10 into multiplication of root 1 by x into multiplication of root 1 minus x cube. But here we cannot do so because there is a term, there is a constant term. So let's convert this 2 into logarithm of base to the base 10. So how we can write 2 as in logarithm form? So now tell me, logarithm of 10 to the base 10 is what?
Which is 10 is the
Think, no problem. Just think about the basic definition of logarithm. It's use the function, and you'll come up with an answer. to what power 10 should be raised to become 10?
Is it 10 again log 10?
To what power 10 should be raised to become 10? Is it 2? Is it?
It's no. What power which is 1, sir?
Yes. There's also one property, logarithm of a to the base a is 1. So yeah, you just have to understand it. So if this is 1, what is logarithm of 100 to the base 10?
2.
Why 2?
10 to the power like 2, which gives you 100 no, so that's why.
Yes, good. That is 1 and 2. So simply we can write 2 as this. Okay.
Okay, sir.
So logarithm of logarithm of 10 is equal to the base 10. So this can also be represented as logarithm of square root of 1 minus x square multiplied by 10 is equal to 2. So now both of the sides are having logarithm, and so basically this on taking anti-log, this will simply become into 100. Understood?
Yes, sir.
Yeah. So now let's go on to solve this simple algebraic equation. This is what a 1 minus x square is what? The algebraic identity, correct?
Yes, sir.
So 1 plus x will be cancelled here. Understood why it will be cancelled?
Yes, sir.
Okay, now this will be cancelled and the power will be remained as 2. So let's bring the and now square root will be cancelled by the square power, correct?
Yes, sir.
Is 100. Okay. 1 minus 100 is equals to x minus 99 is equals to x, which is our answer. Okay.
Yes, sir.
Yeah. And there's one more assumption we have made here, that we have like cutted these values. We have not taken plus minus of plus minus of square root value. If we take, so like the equation will be written in this format. So what they have done is they have made like taken common from these and make this equation, and again this equation will not be having uh satisfactory solution, like if x cannot be plus minus 1, because if x will be 1, so its value will be 0, which will make our logarithm function not defined. If x will be minus 1, then this logarithm function will not be defined. That's why this value will be neglected, and the other value which we have found out will be considered. Okay, understood?
Yes, sir.
And how have they done so? Is basically they have taken common. Uh, they have brought this whole equation to the left hand side, and 0 will be on the right hand side. So what is common in between these two? This can be further, like a raised to power 3 by 2 can be written as a raised to power 1 plus 1 by 2. Correct? And it can be rewritten as a to a half. So that's the same concept here, considering a as 1 minus x. Okay, so what will become x plus 1 square root into a raised to power 3 by 2 minus of a raised to power half into 100 is equals to 0. Taking a raised to power half common, and then what's remaining is square root of 1 plus x into a was 1 minus x minus, this is common, so minus 100. So on solving this, square root of 1 plus x, so it will become x plus 1 minus x. We have taken common, and a raised to power 1 is there. So on solving this further, they have written 1 minus x. Okay. Am I doing some mistake? Let's solve it here without considering this is a or something else. So this can be rewritten as 1 minus x raised to power 1 into 1 minus x square root into square root of 1 plus x, and writing this on the left hand side, square root of 1 minus x square into 100 is equals to 0. Now taking this common, this has become what? Square root of 1 a plus a minus b into a plus b, 1 minus x square, okay, into 1 minus x minus of square root of 1 minus x square into 100. Now we are able to better visualize. Taking square root of 1 minus x square common, 1 minus x minus of 100 is equals to 0. Now it has become the same. Okay, that's how they have written it without describing the step. So we will go on to find out the value of x. From here, we'll find out the value of x as minus of 99. From here, we will come to know and find out the value of x is equals to 1 plus minus 1, which neither values can be possible in this case, because if we will take these values, logarithm function will not be defined. And why so? We have already discussed in our concept part when we are discussing logarithm, that that for any that for any positive integer, for any power of positive integer, it just cannot be negative. So that's the reason behind logarithm getting not defined. Okay,
Yes,
understood?
sir. Yes, sir.
Going to the next example. Very easy question. So we'll try to basically separate this. If logarithm of a to the base, so let's write it as logarithm of a, logarithm of b. So if we'll do so, we will take logarithm of b as common. So logarithm of b will go in the numerator part. What is remaining here? The LCM will get multiplied with 1. So logarithm of b plus what is remaining here? Logarithm of a plus logarithm of c. Are you able to understand how have I done so?
Yes, sir.
Yeah. So same goes for other also. In this case, c is the logarithm of c is the LCM. Logarithm of c plus logarithm of a plus logarithm of b. Plus in this case, logarithm of a will be the LCM. Logarithm of a plus logarithm of b plus log of c. So we know logarithm of m plus logarithm of n is equals to logarithm of mn. Same goes for all these situations. And we can also see that we can take a LCM of all these. So let's write it as um, logarithm of a, logarithm of b plus logarithm of c. And this is what? Logarithm of b plus logarithm of c plus logarithm of a. So this cancels numerator and denominator, which comes as understood?
Yes, sir.
Yes. So it is given as same in the question also. They have taken LCMs, and that has gone further to make the numerator and denominator equals. Going forward, if x is equals to 9 is the root of the equation, there is logarithm everywhere and the base is also common. So we can apply the logarithm property. Now, please note this point. We will not be able to apply logarithm properties if base are different. Like for these properties, when we are writing logarithm of m, This will make out as logarithm of mn. For these two, there should be a common base all over here, right? So here is a common base, that's pi, so not a problem. If it is in subtraction, so it will get divided to the base pi. Now, after taking anti-log to the base pi, basically these two terms, these will be vanished. Okay, so now a minus 2 cancels a minus 2. Now I will go further on to solve this equation. We can write this in this format, right? Understood?
Yes, sir.
Yeah. So as it was given that x is equals to 9 is a root of the equation. So this is a quadratic equation. Can you support this? We can make this a quadratic equation in terms of a, because there's a also, and we can consider x as a constant, and also we can consider it as a quadratic equation in x. There's x square and x term also. So if the given root is in terms of x, let's consider this quadratic equation in the terms of x only. So what we will do now, we will try to find out two roots whose multiple like alpha beta's multiple should be 15a square, and whose sum will be 8a. So if you think of 8a sum as a 3 and 5a, so its multiple will be 3 into 5 15a square, and the sum is also 8a. So these values are satisfying, right?
Yes, sir.
Yes. So let's expand the quadratic equation as per our convenience. Now let's take common, which is x minus of 5a, minus 3a common, x minus of 5a. Now taking x minus 5a common, what is remaining? What is remaining here? X minus 3a equals to 0. So as per this quadratic equation, either x is 5 x is equals to 5a or 3a, and it was given in the question that one root is x is equals to 9. So let's take 9 is equals to 3, because it will give us a value of a, because 3 is like basically multiple of 9 is a multiple of 3. So let's equate 9 to 3a. That will be convenient for us. So 9 is equals to 3a, a will be 3. And we had to find out uh, then the other root. We had to find out the other root. So one root is 9. We have found out the value of 3. We have find out the value of a. Now let's find out the other root. X is equals to 5 into 3, which is 15. So the other root will be. Is this question clear?
Yes, sir.
Yeah. So this is the solution. And there are no more examples right now in this slide. Any other questions regarding logarithm?
Mm-hmm. No, sir.
So let's move on to other slides then. Okay. Hmm. So these are all values in terms of 10. So logarithm of 1 to any base is simply 0, and logarithm of 2 to the base 10 is 0.3010. Logarithm of 3 to the base 10 is 0.4771. Just remember 0.47, and a logarithm of 5 to the base 10 is 0.69. These are important. You have to learn them. Otherwise, sometimes it is also given in the question, but I'll uh, urge you to learn. Okay. So for this practice class, we are going to just remind them simply. Logarithm of 2 to the base 10 is what? 0.3010. Logarithm, that's basically 0.301. There's 7, there's 9. So not a problem to remember one more digit. Logarithm of 3 to the base 10 is 0.477. Logarithm of 5 to the base 10 is 0.699. Okay, so the first question is based on our property which we were discussing earlier. Let me write the property for you. Uh, Now the inequality sign will be decided. It will remain the same for case of a being more than 1. We will change to the case being a less than 1. So now tell me what will be its answer. Try, you can try, and you can also give wrong answers. No problem for that. Please try.
Yeah, sir. 1 minute.
Nandra and Tanish are also here. For how long you are here? Like I didn't notice.
Sir, is it 1 minute? If A is greater than. Is it option C?
Yes, it should be option C is partially correct because x is going to be like let me write it here. X and 1 raised to sorry 10 raised to power 1, and the inequality will also remain the same because the base is more than 1. Okay. So x is less than 10. That's true, completely true. But also we have discussed about the property that whichever is visible with the logarithm function x in the base should be positive. So we will apply one condition also that x will be positive here. So this will be our correct answer. You are also correct. Okay.
Okay. Yes.
So understood everyone?
Yes, sir.
Okay, that's done. Move forward to the next question. We have already discussed it. Have we? No. We have discussed, we have solved for it. We have not discussed it. So simply let's try, do it again, no problem. Square root of 1 plus x into square root of 1 minus x raised to power 3 equals to logarithm of 10 to the square root of 1 plus x square into 10 raised to power 2. Why so? We have changed to as logarithm of 10 raised to power 2 to the base 10. Simply that's why. Understood everything till yet?
Yes, sir.
So after taking anti-log, logarithm will vanish. And now we'll observe this. So what is this? What is this? This can be written as square root of 1 plus x to square root of 1 minus x. Okay, let's do it differently. Let's expand this. Square root of 1 plus x into square root of 1 minus x into square root of 1 minus x square, and square root of 1 minus x square into 100. So what is this? A plus b into a minus b, 1 minus x square, and the square root was there. Square root of 1 minus x whole square will make it as the square root will vanish. Understood why so?
Yes, sir.
Okay. Now let's bring this term to the left hand side. The positive sign will change to negative, and this will be equal to 0. After taking square root of 1 minus x square common, 1 minus x minus in 100 is equals to 0. So now tau. So either 1 minus x square can be 0. So 1 is equals to x square, x is plus minus 1. Or if we solve this further, 1 minus 100, that is minus of 99 is equals to x. So this can be other value of x. Now let's look at the solution. Let's look at the given question. So if we'll take the positive value of x, so there will be a 0 here. So the function will become, so logarithm function will become not defined. So we cannot take the value of x equals to 1. We cannot take it. When we'll take x equals to minus of 1, so this will be 0. So this term will be not defined. So we can also not do that. If we will take log x is equals to minus of 99, then what happens is this term will become imaginary. How so? 1 minus 1 plus x, so 1 minus 99, it is minus of 98. So logarithm, sorry, I have got this stuff. Its answer maybe is none of these or no solution. I'm trying now. So logarithm base 10 square root of minus 98. It's an imaginary number now. Okay. And what will happen here will also say similar thing. And here 1 minus of minus 99, 1 plus 99. So it will become it will become 3 basically. Logarithm of square root of 100, square root of 100 will be 10. Logarithm of 10 to the base 10 is 1. So it will become 3. So plus 3 is equals to logarithm of 10 square root of, that will be something very huge number which will be imaginary. So it will be hard to equate these numbers because 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 we'll be having imaginary numbers. So I'll go with the option number C in this condition. Okay, let's see. Do not satisfy the domain. Yeah, option number C is also given here because it's not satisfying our domain. For taking x is equals to minus of 99, our logarithm function will not be defined. That's why. Understood, or should I explain more? Yes, please respond.
Yeah, understood, sir.
Okay, so the next question, logarithm to the base is common. So let's use the property, it will be multiplied. So we have used the same property, logarithm m and there logarithm of m plus logarithm of n having same base. So they will be multiplied and having same property we have used here. Now let's write 6 as per convenience in terms of like how we can write 6 after giving it as a base of. So we can do one thing here is that let's solve this property. We were discussing about logarithm of x to the base a being having an equality with p. So what we'll do first, we'll bring the base to the other side of the inequality, and now decide whether the base is lying between 0 and 1, then the inequality will be changing. Otherwise, if the base is more than 1, the base is more than 1, so the inequality will remain the same. Here also, xy 2 raised to power 6. So now this is what? So if we understand one fact, and it requires some, it is have some prerequisite of knowing about sequence and series. There are like there is a concept that arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean of two numbers. So arithmetic mean of two numbers is what? X plus y by 2, and geometric mean of two numbers is xy square. Harmonic mean is 2xy plus divided by x plus y. So basically now we have xy in the equation, in the picture. We do not know about x plus y. Sorry, we need to find out about x plus y. So let's use this inequality. Okay, further x plus y we need to find out. So x plus y divided by 2 will be greater than or equal to square root of xy. Xy is what? Xy is so we know in this case that the geometric mean will be greater than 2 raised to power 6 or equal to 2 raised to power 6. And now we know in this condition that arithmetic mean will be greater than or equal to Zm. So it may be written, it can be written in this situation that um, so the least value of xy is 2 raised to power 6 here. And we need to find out the least value of this only, or what we need to do is um, let's do one thing. Let's create space for us. Taking square root on both sides. Sorry, 2 raised to power 6 divided by 2 because of square root xy divided by 2, 3. Okay, clear till now?
Yes, sir.
So arithmetic, this is our geometric mean, is greater than geometric mean, and geometric mean is itself. So can we write using this condition that what? Let's take an analogy that 3 is greater than 2 and 2 is greater than 1. So can we write 3 is greater than 1?
Yes, sir.
Yeah. So similarly, we will do this also, this only, that arithmetic mean will be greater than or equal to 2 raised to power 3. What is arithmetic mean? X plus y by 2, 2 raised to power 3. And now we had to find out about x plus y. So let's bring this 2 on the right hand side. On doing so, the 2 raised to power 3 will get multiplied by 2, so its power will increase. So now the inequality says x plus y is greater than 2 raised to power 4 or equal to 2 raised to power 4. So the least value of x plus y is 2 raised to power 4 as per our calculation, which should be 16. 2 raised to power 4 is 16. Is this clear? And this was a like prerequisite for the uh, solving this question. This is a concept which will read in sequence and series chapter. Sorry. Okay, understood?
Yes, sir.
Any doubts?
No, sir, no doubts.
Yeah, they have also done the same. Same base. Great. So we have to find out the least value for this. Okay. So base 10 here, but no, base is x here. So there is a little typical situation. So how we can write this in terms of 10? Is that we can write 1 by 100, right? 1 by 100 can be written as 1 by 10 raised to the power 2. It can be further written as 10 raised to the power minus 2. Correct? Correct?
Yes, sir.
Understood? Yeah, so writing it further to logarithm of x to the base 10 minus into logarithm of x 10 raised to the power minus 2. Now solving it further, taking minus 2 ahead because it's in power. So 2 logarithm of x to the base 10 minus into minus of 2 will become plus of 2 logarithm of 10 to the power to the base x. So taking 2 common here and writing it as logarithm of x to the base 10 plus we can write it as, and we can change the base while changing its we can change the base while changing its position numerator and denominator. Will bring it into the denominator part and we can write it as logarithm of x to the base 10. Is that clear? Is that clear, everyone?
Yes,
Should
sir.
I repeat?
No, no.
So logarithm of 10 upon logarithm of x, and if we bring logarithm of x by logarithm of 10, so what is this? 1 by logarithm of x to the base 10. Correct? That's what we have done. So okay, so now understand one thing, that do you agree with me that logarithm of x to the base 10 is a positive value? The
Mm,
result of this logarithm function will be positive. Is that correct?
yes, sir.
And there is a property which says, let me write some different alphabet, m plus 1 by m. If m is real and positive, okay, so the least value of this term will be 2. The least value will be 2 because m is a positive number. Let's take any number. Let's take m is equals to half. So this will be half plus 1 by half, it will become 2. So it will become 2.5, which is more than 2. If you take m is equals to 2, so 2 plus 1 by 2, which is again 2.5. Let's take m is equals to 3, 3 plus 1 by 3, which is 3.333, right? Which is still greater than 2. If you take m is 1, 1 plus 1 by 1, there is 1 plus 1, which is 2. It is the least value possible for this expression. So this is a very, very important concept. I remember that I have taught this concept particularly earlier in our earlier classes. Anyways, if you don't remember, you can write now. Okay, take a note of this. Is this clear that why it is happening?
Yes, sir.
Yeah. So if this is also positive, so we can write logarithm of x to the base 10 divided by logarithm of x to the base 10. These both are positive, then these both are same. So same kind of inequality will also be applicable here, that its least value will also be 2. Do you agree? Clear?
Yes, sir.
Yes. So we have to find out about 2 into. So let's multiply 2 on both sides. So 4 into 2 into logarithm of x to the base 10 plus 1 by logarithm of x to the base 10. So our the expression's least value is 4. So we have to find out the same. Okay,
Yes, sir.
understood? Any doubts?
No doubt, sir.
Good. So let's now discuss the last question fastly. So bases are different and n is common here. So why not making n as the base? So that will be more comfortable applying the properties. Okay, so the logic is clear why we are doing so. That let's change the basis to n. By logarithm b base n, logarithm of c base n plus logarithm of c base n. Sorry, not addition. Logarithm of a base n. Now the bases are common. So let's take what we can do here. We can also not apply properties right now here. So let's take LCM. Um, LCM will be logarithm of a base n, logarithm of b c, sorry, base n. And if we'll take logarithm of c also, so now this particular term will divide all of these terms. So do you agree how, and are you able to understand how I have written the LCM show?
Yes, sir.
So when this term will get divided by this, so what will be remaining? When this will be divided by this, what will be the quotient?
Means law, which law? A, B.
This term is getting is getting divided. This is getting divided by this.
Law, then log C will be there.
Yes, my efforts. Dumb, dumb, dumb. So this will be remaining, right?
Yes, sir.
So similarly here, logarithm of
A,
yes. Here,
B.
yes. So now here we can apply the property. They are in addition, the base is same. So and children often get confused with this property, that we can also write this as logarithm of n c plus logarithm of a to the base. And no, it's different. The property was not this. The property was not this. Let me clarify. Let me clarify. It was logarithm of m to the base a plus logarithm of n to the base a into logarithm of mn to the base a. It was not that logarithm of m to the base a getting multiplied by logarithm of n to the base a will be written as logarithm of m plus n to the base a. No, this is a complete lie. Okay, this is not true. This is not true. And here, this is big confusion in logarithm. Okay, for starting only, only for starting. If you are aware about this confusion, then you will not make this kind of mistake. So, are you able to understand that? What is the difference in between these two?
Yes, sir.
Okay. So solving the question further, ABC will get multiplied base n divided by logarithm a n logarithm b base n logarithm c base n. So let's now try finding out some option which can match. Hmm. Okay. So logarithm of ABC, like in most options, this is in the denominator part. So it's an intuition. Let's bring this into a to denominator part and let's solve it further. What do it says? Now, hmm. So bringing this, let's now change the base again, and let's see what happens next. Okay, on changing the base, logarithm of n to the base a, logarithm n to the base b, logarithm of n to the base c, divided by logarithm of n to the base a, b, c. So what is this basically? Now let's separate the bases and others. So this will be logarithm of n divided by logarithm of a, logarithm of n divided by logarithm of b, logarithm of n divided by logarithm of c, and also this logarithm of n divided by logarithm of a, b, c. So this logarithm of n will get cancelled by this, and are we missing the track? Okay, I guess no. Right. We can also try one trick here whenever we are stuck with in this kind of calculation. So we can assume A, B, and C, okay, and also N, so that all our options are different, and like after putting the assumption substitution, after we have substituted our assumptions, so all the options are different. Now then we'll go on to solve the question further, and we'll mark the option whichever is matching. So that often works, most of the times work. So our now simplified version is here only. So let's try that assumption method, in which we will assume the value of a as 2 raised to power 1, b as 2 raised to power 2, c as 2 raised to power 3, and n as 2, basically. Okay. So this will become logarithm of ABC is what? 2 raised to power 1 plus 2 plus 3. So 6 base 2, logarithm of at 2 logarithm of 2, that's 2 raised to power 2, logarithm of base 2, c is what? 2 raised to power 3. So this has become 1, this has become 2, this has become 3. Understood why so? This has become 6.
Yes, sir.
Understood why so? Yeah. So this will become 6 by 1 into 2 into 3. 2, 3 cancels. So answer should be 1. Now let's check while putting ABC as this is 2, this is 4, this is 8, and n is 2, which answer will be 1. So I'm guessing on the option number 1, and we'll have to check all the options, because what if two options will have same answer as 1? We cannot take a risk there. Then we have to go for some other assumptions. So logarithm of let's simply find out. Okay, logarithm of 2, the base 2 will be 1, into logarithm of n, which is 2, 2 raised to power 2. This is half. Okay, this is half. This is half. Come on, right? Yes. This is logarithm of n, which is 2, logarithm of n, which is 2, and c, which is 2 raised to power 3. So 2 raised to power 3. So which this is half logarithm of 2, 2 raised to power 3, which is 1 by 3. So this has become 1 by 6 in the numerator, and in the denominator, logarithm of 2 ABC is what? 2 raised to power 6. So this has become 1 by 6. How so? Do you know? Are you able to understand why it will be 1 by 6?
Yes, sir.
Completely, na? Please don't be pressurized by time, or we have complete time, no problem for that.
No, no.
So it is the same property. Let me still explain that m raised to power n and a raised to power b. So we can write it as n will get multiplied and the power of base will get divided. That's how we have written so.
Okay.
Okay.
Yes, sir.
So this is getting our answer as 1. Now let's check for other options. This was what? 1 by 6. This is also 1 by 6. Logarithm of 2, 2. This is 1. So 1 by 6 is not the answer. Let's check for this. The denominator is 1 by 6 because we have already find out its value in the option A. So let's utilize our memory. 1 by 6. Bro. Yeah. A logarithm of 2 to the base 4 will be half. So this is somewhat 3, which is also not our correct answer. So our assumption solution is matching with our option number A. So that's why the answer will be A. Understood?
Yes, sir.
Yes. So yeah, and we have already solved the question. Oh my God, why haven't I noticed and matched with the option C? See in the slide here. Logarithm of ABC. If we have just like reverse this, if we reverse this, so it will become option number A only. Understood?
Hi, yes, sir.
Okay, no problem. But still, we learned one more method, which is an assumption method, and it is very effective to solve question in a like fast manner. So, without solving this much only, if we have just assumed it, uh, oh, brother, continue, continue. You give me some space. So simply, this was our question, and if we didn't want to solve it, so directly assuming, and why we have assumed 2 in terms of power only, because we know it will be convenient for us to solve. So A as 2, B as 2 raised to power 2, C as 2 raised to power 3, and as 2. So N as 2, 2 raised to power 3 is there. So if we just solve the question statement, logarithm of 2 to the base 2 should become, let me not waste your time. 2, 2, this will be 1. 2, 2 raised to power 2, this will be half. 2 and 1, 2 raised to power 2, this will be half. 2, 2 raised to power 3, this will be 1 by 3. 2, 2 raised to power 3, this will be 1 by 3. This is 2, this is 2, this is 1. So what is it? What is this becoming? What is this becoming? 1 by half plus 1 by 6 plus this is what? 1 by 3. Okay. Taking LCM as 6, 3 plus 1 plus 2, which is 6 by 6. 1.
1.
If we eliminate all our options, we substitute our assumption. This was becoming as maybe 1 by, this was becoming as 1 by 2 or something, this was becoming as 3, this was becoming as 1. So our option number A is correct. So this is also one more method. Understood?
Yes, sir.
Yes. So any other doubts from logarithm chapter? We have completed it.
No, sir.
So I just want you all to remember the properties again. I will be sending this class notes again in the class notes PDF again in the Omega Maths classroom notes. So please refer to that. And again, I repeat that please learn the whole exponents of 2 raised to power 1 to 2 raised to power 5, 3 raised to power 1 to 3 raised to power 4, 5 raised to power 1 to 5 raised to power 4, and squares and cubes of all numbers from 1 to 20, and you can leave the number 1. For me, I'll learn the squares and cubes of 1. Okay?
Okay, sir.
Okay, thank you everyone. Jai Hind.
Thank you, sir. Jai Hind.